Assalamu alaikum everyone. Today we will start explaining petroleum and petrochemical processing. So we will start with chapter 2, composition of crude oil. Crude oil is made of two main groups, which are hydrocarbons and non-hydrocarbons. Hydrocarbons, main part. They make up about 95% of crude oil and are divided into three types or three parts, which are aliphatics, which is about 25%, and aliphatics consist of alkanes, which are saturated hydrocarbons, and alkenes, which are unsaturated hydrocarbons, and they could be in straight or branched chain. Then we have naphthenes. They are about 50%. It's like about cycloalkanes. They are ring-shaped saturated hydrocarbons like methyl cyclohexane and cyclohexane. Then we have aromatics. They are called aromatics because they have a pleasant smell. That's why they name it as aromatics, and they are about 17%. Then example for aromatics like benzene and toluene. Then we will go for non-hydrocarbons. Non-hydrocarbons are elements. They are usually called impurities, non-hydrocarbons, like sulfur, nitrogen, oxygen, and metallics. Then paraffins are alkanes, such as methane, ethane, propane, and butane, and isobutane, and pentane, and isobentane. They are saturated hydrocarbons. So when you see alkanes, you can remember, you can memorize that they are saturated, and carbon-carbon bonds are single bonds, and they undergo substitution. So alkanes, you can remember it through 3S, SSS. So they are saturated, single bonds, and they undergo substitution. Then paraffin compounds are primarily obtained as a gas fraction from the crude distillation. The molecular formula is CnH2n+2, where N is the number of carbon atoms per hydrocarbon molecule. The first four of family are methane. These are examples of alkanes or paraffins, and these are also another example. These are the structural formula for alkanes. We have here methane, ethane, propene, normal butane. No, okay, there is something wrong. This is propane, not propene. Okay, then butane, bentane. It's not pentene because there is no double bond here. Then we will go for naphthenes. Naphthenes or cycloalkanes, such as cyclopropane. They are not aromatic. What does that mean? Aromatic like benzene, and benzene contain double bond. So naphthenes are not aromatic because they are not consisting of double bond, and hence do not contribute much to the octane number. So what does octane number mean? It means it is a measure of how well a fuel resists knocking. And knocking means irregular fuel explosion inside the engine. So when we have, when the fuel is less resistant to knocking, so the performance will decrease. So we need to have a high octane number. So high octane number means smoother combustion, so better engine efficiency and performance. In the reforming reaction, these compounds are targeted to generate aromatics which have higher octane numbers than the naphthenes. In this process, naphthenes are converted into aromatics like benzene, toluene, xylene. Aromatic compounds have much higher octane numbers than naphthenes. So converting naphthenes into aromatics improves the fuel quality and performance, as we said. And we have another name for naphthenes: alicyclic hydrocarbons and cycloalkanes. and the structural and the molecular formula is CnH2n. These are examples of naphthalene. They are cycloalkanes, cyclopropane, cyclobutane, cyclopentane, cyclohexane, and methyl cyclohexane. You can see it by yourself. Previously, we talked about alkanes, which are saturated hydrocarbons. Now we are talking about alkenes or olefins and alkynes or acetylenes, which are unsaturated hydrocarbons. So alkenes or olefins, they contain carbon-carbon double bonds, and they are called unsaturated because they contain fewer hydrogen per carbon than alkanes. And their molecular formula is CnH2n, which is similar to naphthenes, but naphthenes are having single bonds, carbon-carbon single bond, and they come in a ring structure. However, alkenes, they have double bonds. That's why they are unsaturated hydrocarbons. Then they are highly chemically reactive, so they are highly reactive than alkanes. However, they are unstable, so they are less stable than alkanes. So CN2N, their molecular formula, and they have double bonds. Then these are the examples of alkenes or olefins: ethylene or ethene, propene, propylene, cis-2-butane, trans-2-butene, butene I mean. So then acetylenes or alkynes, they have triple bonds, carbon-carbon triple bonds, and they are unsaturated, as we said, and they are the most reactive hydrocarbons, so they are more reactive than alkanes and than alkenes. However, they are less stable than all the other types of hydrocarbons. Crude oil contains many types of hydrocarbons, as we discussed before. Among them is a group called aromatics. Examples are benzene, toluene, and xylene. These compounds naturally exist in crude oil. Aromatics have a ring structure, and they are all based on the structure of benzene, which is a ring made of 6 carbon atoms with alternating double bonds. So any cyclic compound that has this benzene-like structure is considered aromatic. Aromatics are an important class in petroleum, with the basic building block benzene, C6H6, and toluene is basically C6H6 plus CH3, so its molecular formula C7H8. And xylene, it has C6H6 plus C2H6, so the molecular formula of xylene C8H10, and OMP means ortho, meta, para. They describe where two substituents or groups are attached on a benzene ring. So in ortho, groups are on carbon 1 and carbon 2, so they are next to each other. However, in meta, the groups are on carbon 1 and carbon 3. And in para, groups are on carbon 1 and carbon 4, they are in opposite sides. Aromatic hydrocarbons contribute towards higher octane number products, and the target is to maximize their quantity in a refinery process. Aromatics burn more smoothly in a gasoline engine and resist knocking, as we said about the octane number. So, therefore, in refinery operations like catalytic reforming, the goal is to increase the amount of aromatics because we need to have better gasoline quality and higher octane fuels. The higher octane number, the better quality of the fuel. Then these are the examples of aromatics: benzene, C6H6, toluene C7H8, so it is like a benzene plus CH3. Then para-xylene C6H6 benzene structure and benzene ring and 2 CH3. Then orthoxylene, metaxylene.